Hello everyone. In this video, we'll discuss about significant figures. So watch the video till the end. First, we'll discuss what is significant figures or significant digits. Significant digits are the digits which give us useful information about the accuracy of a value. Significant figures are the number of digits in that value that carry meaningful contributions to the degree of accuracy of that value. The accuracy of a calculated value will depend on the number of significant figures. The value will be more accurate if it is given to a higher number of significant figures. We start our counting for significant figures from the first non-zero digit from the left side. Say we have a number 0.00082. So here the first non-zero digit is 8. So the first significant digit is 8 and the second significant digit is 2. Now we will discuss rules for counting significant digits. The first rule is all non-zero digits are significant. As for example, we have the number 2873. Here all the digits are non-zero, so the first significant digit is 2, second significant digit is 8, third significant digit is 7 and fourth significant digit is 3. So here all the digits are significant as all the 4 digits give us useful information about the measurement of the number, and we are sure that the number is exactly 2873. So in this number we have 4 significant figures. The second rule is leading zeros are not significant. As for example, we have the number 0.0043. Here these zeros are leading zeros and the first non-zero digit is 4. So the first significant digit is 4 and the second significant digit is 3. So in the number 0.0043 we have 2 significant figures. And it is interesting that we are not including these leading zeros as the significant figures. Of course, these leading zeros help us define the number, but they are just placeholder and they serve only to put the non-zero digits in correct positions, and they only provide information about the size of the number. But these leading zeros are not telling us how precise the number is. We can understand this clearly if we consider this number as a distance in kilometer. Then in meter it will be 4.3 after multiplying that number by 1000. So here we see that there are 2 digits only, 4 and 3, and the leading digits are not present here. So as these 2 numbers represent the same distance, so from here we see that the leading zeros does not tell us anything about the accuracy of the number, and only 4 and 3 are significant here. So in the number 0.0043 the leading zeros are not significant and 4 and 3 are the 2 significant digits, and hence in this number we have 2 significant figures. Similarly, in the number 0.0001504, these zeros are leading zeros and hence these are not significant. So here 1 is the first significant digit, 5 is the second significant digit, 0 is the third significant digit and 4 is the fourth significant digit. So in this number we have 4 significant figures. The third rule is zeros at the end of a number are significant if there is a decimal point. So we have the number 0.00630. Here these zeros are leading zeros and these are not significant. So the first significant digit is 6, the second significant digit is 3, and it is interesting that this 0 is also significant here. This trailing 0 tells us that the measurement was made accurate to this last digit. This implies that it was measured up to the 100,000th digit. If it was measured up to the 10,000 digit, then the number would be 0.0063, which is correct up to this 10,000 digit. But the previous number implies that the number 0.00630 is correct up to the 100,000 digit. For this reason, in the previous number, that means 0.00630, we have 3 significant figures, and the trailing 0 is also significant. And in the number 0.0063, we have 2 significant figures, and it is obvious that there is a difference between these two numbers. In the next example, 480, the first significant digit is 4, the second significant digit is 8, and the trailing 0 is not significant here. So the last 0 is not significant here. Actually, we don't know anything sure about the unit digit here. That means we are not sure about the trailing 0 here. As it may be the case, say we may have rounded say 484 to 2 significant figure to get the number 480, or it may be exactly the number 480. So we are not sure about the trailing 0, the unit digit. It may be 484 corrected up to 2 significant figure to get 480, or it may be exactly 480. So for this reason, the trailing 0 is not significant here, and in the number 480 we have 2 significant digits, 4 and 8. For this reason, in the number 480 we have 2 significant figures. But in the next example, 480 with a decimal point, we are sure that we have calculated up to this unit digit, that means up to this trailing 0, and for this reason now this 0 is significant. And in the number 480, including the decimal point, we have 3 significant digits, 4, 8 and 0, and for this reason in this number we have 3 significant figures. This implies the number was corrected up to the units digit 0 up to the trailing 0. In the next example, 480.0, here the first significant digit is 4, the second significant digit is 8, and both zeros are also significant here. And the last 0 tells us that the number was made accurate up to this 10th digit. And for this reason, in the number 480.0, we have 4 significant figures, and the trailing zeros are significant. The fourth rule is any zeros contained between non-zero digits are also significant. Here we have 2 zeros, and these 2 zeros are contained between the non-zero digits. for this region these two zeros are also significant, and hence in this number we have 6 significant figures. In the last example we have the number 200.034, and here these 3 zeros are contained between these non-zero digit, and hence these 3 zeros are also significant, and for this region in the number 200.034 we have 6 significant figures. That's it. Thank you everyone.